thank you very much. I have a mixture of slides. I'm going to talk a little bit from my script here, so don't get distracted. Okay, transparency in social science research and teaching. I want to say a few things about myself, just so you know why I'm interested in this field and why I talk about this so much. I teach methods for social science students, graduate students, in the Department of Sociology. We have a center, the Social Sciences Research Methods Center, SSRC, that teaches actually all the different social science fields, land economy, psychology, political science. So I see a lot of different students, and a lot of the students want to learn statistics, or some of them have to. And the best way to teach them, apart from the regular textbook courses on how to do regression, in my opinion, is to replicate published work. So I've started asking students to just replicate a table from a paper to learn how regression works. And so sometimes the students can get the data from the published paper, and lots and lots of things I'm going to talk about in a second. And so this got me into kind of thinking about how I can embed transparency and reproducibility into teaching more, and at the very core, at the beginning of a research career. So this is how I came to this kind of topic. So one of the most difficult, I started to create a course. One of the most difficult courses that I teach is a workshop where students do only replication. They take a published study and try to reproduce the results. That's the course where the students learn the most, and that's also the course that students hate the most because it's really frustrating. In the course, it's called the Cambridge Replication Workshop, they also learn how to work transparently themselves. So I asked them to upload their own data, to share their code, and to work really transparently when they run their own replication. And this is going to be at the core of what I'm going to talk about today. One of the main questions in the social sciences, and I believe also in the natural sciences, is what can be done to improve reproducibility and research transparency? And my perspective is to put graduate students and early career researchers at the center. I think that they are the key to improving transparency. So let me start by sharing a few emails with you that I have that have been a source of great frustration for me. I also replicate studies, but mostly because I want to learn how the other scholars in my own field on human rights and globalization, how they ran the latest tests, what kind of cutting edge, I don't know, R codes and R packages they use to run their analysis. And so I occasionally write to authors who, most of them I know now quite well, and ask them for their replication data. And so these are answers that I've received in the last few years. Hi, Nicole. I only have some of my electronic files with me during this trip, but the material from the article is not among them. I would be happy to collect these for you once I'm back and have access to all my files. All the best, so and so. So I never got these data, even after following up months later. Another email. Nicole, I will definitely send the data when I can clean it up a little bit. Let me see what I can dig up. So I never heard back. And the third one, Nicole, I would be more than happy to share my data with you, but I'm currently swamped and I don't have time to clean up the data set that you requested. So you can guess that I've never received those data. So such emails reflect the state of irreproducibility in the social sciences. A recent study found that 18 out of 120 political science journals actually don't have a replication policy asking authors to upload their data sets. And the journal Nature has recently done a survey, some of you might have seen that, a survey among scholars on transparency, and what were the results? More than 70% of researchers have tried and failed to reproduce another scientist's results and experiments. More than half have failed to reproduce their own experiments, and 52% agree that there is a significant crisis of reproducibility. So that means that much of the knowledge that we trust today is actually unchecked. So let me give you a few examples of how the media have reacted to this. The Economist, How Science Goes Wrong. The New York Times wrote an article, why do so many studies fail to replicate? Or again, The Economist, Trouble at the Lab. Scientists like to think of science as self-correcting, but it actually isn't. And this was in the Times Higher Education. More than half of psychology papers are not reproducible. So I'm sure you've seen these kinds of stories in the news. There are a lot of different kinds of scandals and a lot of things going on. So I argue that the reproducibility crisis can be tackled by emphasizing research transparency and replication of other work in graduate student teaching and training and in staff training for early career researchers. So I'm promoting that universities invest time and money into helping students and staff to learn how to work transparently, what are the tools, what softwares can they use, which web pages, and also to help students and early career researchers to replicate their own work before they submit it to a journal, and to replicate the work with others. I'm really convinced that this will ensure that the gold standard of scientific research can be upheld by implementing transparency tools more efficiently. So how can this work in practice? I want to talk a little bit about the replication workshop. It's an interdisciplinary workshop. I have about 20 students each year from all the different fields in the social sciences, and they choose a paper from their own field, something close to their own research. They download the paper, and then they try to download the data set, and then it goes on and on. So they have 8 weeks of reproducing the results and then extending the study. In the first 4 sessions, we really only focus on picking the right paper, so having a study that you can actually reproduce where you know all the methods, downloading the data, trying to reproduce exactly the same results. If you're lucky, you can get the code and rerun the code to get all the tables. That hasn't happened yet. In the second half, the students really think about what can they improve in the study. Is there a better, newer measurement or anything like that? And so they try to extend the study and then write up their own paper and submit it to a journal. First to a conference usually, and then to a journal. So what are the challenges? Students were confronted with 6 different challenges. The first one was they couldn't find the data the original author used. The original author didn't answer to any kinds of emails where they asked for the data or asked for help replicating the study. The authors answered, but they didn't remember where they had the files. The methodology section in the paper was not really well described, so often it wasn't really clear what exact model was applied. It wasn't clear how the variables were transformed. Were they logged? Was this divided by this? Was it GDP, GDP current, GDP per capita? Was it for direct investment, flow, or stock? So often it wasn't really clear what did they do with the data. And the statistical models remained opaque. Often you read something like, we ran a regression model, but that doesn't really specify everything. So this irreproducibility across all the social science fields led to massive frustration among my students. And it demonstrated a lack of transparency in the field, and actually in all the fields that the students are from. So the students and I share a Dropbox so that I can go and help them with their code if they have a problem. And one of the students, Nico, in criminology, named all his R files, the software code, Nightmare 1, Nightmare 2, Nightmare 3, really frustrating. So why do students still sign up? And why should you do replications? Okay. So there are benefits. First of all, I think replication is a great way to learn statistics. All my students have said that it's nice to learn something from a nice, clean, perfect textbook example, but you only ever really do research when you work with messy data and bugs and problems. So with these real-life data, students learn much, much more. And they also realize what kind of decisions an author has made. And that is really useful when you write your own papers. You can really see all the different steps the authors took, and then some models did go into the paper, some other models didn't. And I'm not just talking about p-value fishing, but also just sometimes you have to make a decision what is really more feasible to put into the story for the paper and what you're going to leave out. And that is the biggest struggle that my students usually have, because how do you learn that, right? So you can really look what do the published authors do. Second, students can get published early. Several students of mine, 5, 6 students now, have published their replication study as a new article. It sometimes takes a little while longer. You can't really do that in 8 weeks. But if you go back to your lab and then you maybe publish it together with your supervisor, or you find another colleague who says, okay, I'm going to jump onto this project, and we're going to extend it. So several students have published a revised version now, and that was their first paper on their CV. And that was really great just to have that and then add on to that. And most importantly, and that's the third benefit, students create a reproducibility routine. What I do in the course is that students at some point when they have done their analysis, they have to exchange the R code and their paper draft. And then their student partner has to replicate what the other person did to see if the code runs and just to double check if everything was fine. And so the students learn from me, comment your code well and have your data very clean and be really meticulous. And they know that they have to do that because they just replicated someone else's mess sometimes, okay? And so what I found was that students actually had to meet outside of class for 2 or 3 afternoons to talk each other through what they just did. And so they kind of really painfully, and it's really annoying, I totally understand, but they really kind of realize, even when you think your code is very clean, it might not be for the next person coming and trying to replicate. So the students really learn how to work reproducibly in their own work in the class. So I want to give you a few tips in case you want to try this. And I'm going to give you like a 2-minute warning. Yeah? That'll be fine. Good. Okay. So just to be clear, there's a difference between duplication and replication, and I know in different fields there are slightly different names for these, but just for today, a duplication would be that you verify the results of the original paper with the same data and same code and same methods. A replication usually tests the robustness as well, so you would collect new data, change the models, extend the study. And the full replication is publishable. The duplication is more of a kind of a check for errors and learning what the author did. Which study should I pick? This can take really long. Okay, so the perfect replication project is something obviously with impact, an important study in your field. It should be something where the results have been widely accepted, so people believe that, debt is really bad for growth. It is a widely accepted claim, but no one has actually checked it, and that is a good paper to pick. You can often find papers that miss important control variables, confounders. Or some papers, for example, you would write, use certain measures where 5 years later, there has been improvements, there has been a new index. And if you took that improved measurement, you could really see if the results hold. Generally also, the study shouldn't be too old. If it's 5 years back, then it's still okay, but if you go further back, the field might have already moved on, or the original author that you might want to chat with to get some help from them will probably not remember anymore what they did. So it shouldn't be a too old study. So an example is, that's not very cool, okay? Has anyone heard of the Reinhard-Rogoff scandal in economics? Okay, some people are nodding heads. So this paper, really famous paper from 2010, argued that high debt is bad for growth. And so that had a big impact actually on policy making. Well, first it was in a very good journal. but also it was used by governments and policymakers to justify austerity measures. And a student from, I think, either MIT or Gary King's class at Harvard, went and tried to replicate that as a class assignment. And he found that in the Excel spreadsheet, there were some errors. I think one column had just shifted one cell down or something like that. Don't work with Excel ever. But also they had done some weighting and had done some things with outliers that weren't really convincing. So the student, really just as a class assignment, found out that the results actually don't hold. And so he published that together with, I think, another student and a supervisor, or thesis advisor. And that basically got into the news and it was everywhere. New York Times, you know. So this is a good pick. Obviously, it's easy to say that after, you know, this has happened. But just keeping to these few guidelines here is already a good start. So practical steps, I think that's pretty obvious. You pick a paper, you try and get the data in code. Sometimes we have to recollect the data from, I don't know, the World Bank or any kind of official sources. You have to identify each variable, and it sounds really banal, but when you read the cryptic coding, you often don't exactly know what was what. You reproduce the tables and the figures, and then you compare in detail what could you reproduce and what didn't work out. And so this can take weeks, depending on how, it's not always down to the student's skills, but also just down to how well the paper was written. And so if you've done this, this is a duplication. For a replication, a full replication, you can then add value in certain ways, collect new data, new variables, different model specifications. You can also make a theoretical contribution. Someone in my class replicated the paper, but then he actually published a theoretical paper saying that the whole approach of the paper was misguided. So he just decided he didn't want to go down the statistical route, but he said actually when he really closely looked at how the theory aligned with the data and everything, he wrote a theoretical paper. So that's possible as well. And then obviously he would compare if the results still hold and are robust. Get feedback, go to conferences, and then you could submit this to a journal. And unfortunately, this can take months to go. I mean, with any paper, it's like that. But you had a bit of a head start by working off a paper that's already published. So I think that's a bit faster than spending 1 or 2 years on the literature review for a PhD or something. And that would be a full replication. Now, how do you communicate failed replications? Because what I really don't want my students to do is become witch hunters, to try and bring down big names. Most of my students actually get really disappointed when they can't replicate something. They are not out for errors. They feel like they are failing when they can't replicate published results, which is not true. So when you want to publish a replication, it would be good to keep to professional language. So replicators usually write things like, we find that coding errors, selective exclusion of available data, unconventional weighting of summary statistics led to serious errors. That is something that you can definitely say. This is the paper that corrected the Reinhardt-Workhoff paper that I just talked about. Another replication paper said, that was a bit more tough. If we cannot even reproduce the original results using the same publicly available data, there is no need for further commentary. So sometimes I get it done. Now, often the original authors respond back, maybe in the same issue or in a comment in the next issue of the same journal. So, for example, they've written, so these are the original authors. The replication study is less realistic, inconsistent with the substantive literature and of limited utility. The replication is fundamentally flawed. It's different papers. Or there are statistical, computational reporting errors that invalidate the conclusions. So depending on how you frame the replication and how you phrase the errors the other people did, they might hit back. Because it's kind of, we are all trying to be professional, but it's a personal thing. If my paper got ripped apart by someone else, that really hurts. So ideally, be friendly and professional. Okay, how do you publish a replication study? Replication studies can get published. They can't be just a duplication. They should have some add-on that really improves what we've learned. You have to write a solid paper just like any other original paper. What's the puzzle? Why is this relevant? And so on and so on. And in some fields, for example in politics, but it's slowly changing now, you wouldn't want to sell it as a replication paper. So that really kind of depends on your fields. How, for example, in psychology, it is really common now to publish a replication, and it's really, this is really seen as a worthy undertaking. If you're in a field where replication is seen as something minor, not original, you can write something like these authors did, and they say something like, our estimation approach builds off of the methodology and data used by so-and-so, adding measures. So this is the duplication, and this is the adding knowledge, adding value bit. Or another paper here, I revisit these important questions by highlighting some problematic aspects of the analysis of so-and-so. So this is a replication paper, but they are not selling it like that. They are selling it revisited. This is a clue, right? So in some fields, you just have to be practical and just think about how can I convince the reviewers that I have really contributed something. There are a lot of journals open to replication. And sorry. There we go. It doesn't come out very well. So these are just screenshots of journals. I don't know all your fields, but I'm pretty sure in your fields you will also find journals that publish replications. But this is a really high journal, psychology, economics, so there are more and more journals now that accept replications if you want to publish them. So it's worth doing it. And here, these are all replication studies from students or early career researchers that have been published. So I understand that the slides can be distributed afterwards. If you don't need that, you can read it later. So these are all students. This is from one or two. This is from my own student. The other one over there as well. So it can happen. And this is my paper. So if you are a teacher and you want to create a course like that, or if you are someone who wants to replicate, all the information and much more tips and things I've learned from teaching my classes are in this paper here. That is open access, by the way. But one more thing, the students also have to work transparently during the whole process. And I'm sure a lot of you know already what kinds of things to do, but I just want to say, just to recap. When you start out on a project, and this doesn't have to be a replication project, it could be your PhD, for example, or the postdoc project. It sounds so banal, but plan a file structure. I've started actually putting all my projects. You have these 3 folders in my Dropbox: analysis paper, raw data. And the raw data, once I've downloaded them from somewhere, or someone has given a collaboration partner has given them to me, I never touch them again. It might be an Excel or CSV file. The only thing I do is I pull them into my software, for example R, and if I have to change any variables, add something, change around the colors, I put it in the code. I never touch the original data. In the analysis, comment your code really well, and keep a lot of decisions, like a lab book that many of you might know. I have lots and lots of Moleskine books where I've written down all my decisions, because if someone ever comes to me, and it might really happen because I'm kind of outspoken on the topic, so I'm kind of waiting for someone to say, Nicole, I want your data. So I really want to be able to remember and to tell someone why I decided to exclude this variable but keep the other one. For writing up, it's really important to stay clear in the methodology section. There has been a paper, I've published a symposium, like a forum in the journal in international relations. And in this symposium, there was a paper on how good are methodology sections in the field. They just looked how clear they are. Can you replicate a paper from just the methodology part? And most of the time, it's not possible. So So there has been a trend to having a bigger supplement appendix. I know that in natural sciences this is common, but in political science or sociology, this is not really common. So this is something I'm really interested in. And the most important thing, which you can't read because it's all the way down, the line down there, before you submit, replicate your results. I've just done that. I have a student who I occasionally work with. And before I submitted my paper to the journal, I asked him, can you just quickly see if the code runs? And here are all my tables, 30 tables in the appendix. And he got back to me and said, okay, Nicole, so I'm not sure what you did in line 1300 in your code, and this table I couldn't reproduce at all, and the code for table number 8 isn't in your file. And I thought I was so good. Okay. So I really had to go through my code again, and I had some code chunks in another R script which I had to put in, and just he reran everything, and then it worked out. But it would have been really embarrassing because one table just had results from another table in it repeated for some reason. So there were completely wrong coefficients and p-values in there, and that would have been really, really embarrassing. My husband did the same thing. He works in cancer research, and he tried to replicate a figure from the paper within the lab. So in his lab, students and postdocs exchanged their work and replicated before they submit. And they couldn't replicate that particular figure. It was a really nice, cool figure, but they couldn't do it. They didn't know how it worked out, how they did it. And so they took the figure out of the paper and had to find some other way to make it really nice and shiny. And he was really happy because if someone had tried to replicate their work, they might have had to retract the paper, and that was really embarrassing. Okay, what to share? For quantitative researchers, share a README file that just says what's in all the replication files, how to use them, how to run the code. Not everyone works in R, there are lots of other Python, whatever. Obviously the raw data set, all the software commands in whichever form, and information to reconstruct the data. If someone wants to recollect the data by themselves and not just use your data set, how can they do that? And you can publish that on GitHub, Dataverse, they are all free. The Open Science Framework, these are platforms where you can upload big chunks of data and make everything ready. Is there anyone here who is a qualitative researcher? One? Any other? Ah, a few more. Okay, it's fine. I also work qualitatively. I've done a critical discourse analysis of George Bush's speeches. That means reading lots and lots of speeches and getting really tired and trying to make sense of what he said. And so, when you do things like interviews, field notes, or maybe you took videos, ethnography, it is really hard to kind of just say, I'll upload my data set. So in these cases, you can still work transparently, and the American Journal of Political Science has some guidelines for that. They are very long. I just want to say one or two things. A, you can upload your files, for example, videos or field note scans, at the qualitative data repository, which has been created exactly for this purpose. And there are people there consulting on how you can prepare your qualitative files to preserve the privacy and copyright issues, and you want to keep some people anonymous, or you will have to probably, but also on how to still upload parts of your data. What you can definitely do, you can create a transparency appendix for your paper. Even if you can't, for example, publish a whole interview with, say, a human rights activist who wants to stay anonymous, who should not be identified, you can still take some snippets of quotes and just put them in the appendix to prove why you think there's a causal story from A to B. So there are a little bit of, you have to think creatively a little bit, and it's a bit more difficult than just taking an Excel spreadsheet with all your data and uploading it. But there's now a bigger trend where qualitative researchers are trying to do similar things. I'm going to leave this out because I think I might be running out of time. Okay, all right. Well, just maybe the OkCupid story. This is a dating website, And this is a quantitative researcher, someone downloaded or web scraped all the user data and then wrote a small paper about cognitive abilities. I don't know exactly how he tested it, but at OkCupid, you can answer questions. Do you think that 16-year-olds should have sex? Or something like that. Random questions. You can answer them, and I think then the web page matches you with other people. And so he downloaded all the user data, which is possible. So if you log into this page, you can see all the users' things, right? Their profile, their hobbies, their location, their kind of cryptic name. He downloaded all that in one big data set and then did some analysis on it. And then published that. And he wanted to be very transparent and published also the data. And that was a big problem because the users didn't really sign up to be part of that data set. They signed up to be on OkCupid, and they signed up to certain parts being visible to other users who might look for someone to meet, but not to be in this huge data set testing for cognitive abilities. So the researcher, I talked to him, and he really tried to be transparent, do everything right, share the data, but he had one line in his paper saying, anyone who logs into OkCupid can see all the data, so we think there is no ethical issue, we just compiled them into a bigger file. But that was not really the case. So he had to take down the replication data file, and there was a big discussion on a very important topic, which is ethical considerations when you share your data. Along with that goes when you do have to anonymize and when you do have to withhold certain data, especially when you have patient data, it would be good to justify why you withhold the data. So what's in it for me? This is taken from a paper called 5 Selfish Reasons to Work Reproducibly, written by Florian Markowitz, who is my husband. And he got all the ideas from me. Right, so first of all, you avoid disaster if you work transparently. The reason why I try to work transparently and give someone else my code before I submit to a journal is I want disaster before everyone else knows it. I want disaster to be contained and to happen at my desk or in your lab and not outside, right? So you avoid disaster, you avoid possible retractions. It's easier to write up when you do a PhD, which takes 3-4 years, and you did something in your first year and you didn't properly kind of log everything, you might not be able to write down what you actually did. It's easier to persuade reviewers. I'm secretly hoping that some reviewer will ask me to send the data and code just to show how nice I did everything. Because if they say, I'm not sure I trust this table, I can just easily say the next day, here you go, just look at it. And then they can just do it. It enables continuity, so if you do a follow-up project and you have all your files ready nice in one particular place, it's just easier to keep going from that. And 5, I think that is actually really important. You build a reputation for working reproducibly and for trying to be transparent and not having anything to hide. So I'm pretty sure in my papers there are errors, because there are always errors somewhere, and there's always data are never perfect, right? But I think by being transparent, by saying here's everything, just take it and have a look. I'm not untouchable, but no one can ever say, oh, she tried to withhold data, maybe she kind of just made up some data. This can never happen. And so you can build a reputation of being transparent. And if they do find an error, the blow won't be that hard. I know a scholar from Berkeley, Ted Miguel, an economist who does experiments in Kenya, and some of the experiments involve worms and people, and I forgot what exactly the story was. But someone tried to replicate his experiments, and he's a promoter of open science and transparency, so he handed over even the smallest field notes, like books, everything, and they did find an error, not really an error, more something that is difficult to repeat in that particular way. But he never got into the media as someone who kind of like made up data or did scientific misconduct. But it was a very kind of calm report on what he did, the files he provided, and what had to be corrected. And it was fine. He is really well known still for working transparently. He's at the Berkeley Initiative for Transparency in the Social Sciences, BITS. And that was it. And I think that is a really good example that I feel like I have my little safeguard and being transparent. So, build your reputation. Yep. So, in conclusion, I'd like to encourage you to think about doing a replication study, or if you are a PI, maybe talking to your students if they want to try doing a replication study, to integrate transparency ideas into your workflow, and obviously to share your data. When you establish a culture of transparent work, especially for those during the early career researchers, you can be at the forefront of using cutting-edge methods to uphold the gold standard of scientific research. Thank you. We share a class email list, and people often still, a year later or 2 years later, send around a question. I have a bug in R, can someone help? Or they send me an email saying, I'm trying to impute my missing data, can you help me with something? So I'm still in touch with most of the students. Many of them try to publish the replication study, and they also try to upload all their data when they do that. So in that way, I know they keep up, and some of them have thought about how they can teach their students later on, how they can embed that in their own teaching. Now, at the same time, I know, and that happens to me, when you're in your everyday kind of workflow, it is hard to always be super meticulous to write on everything. It's just really hard. It's time-consuming, and you're thinking, oh, I'm just going to try out this figure, and then you get distracted and you do this. So I think no one can ever, and the students, I'm pretty sure, can't be perfectly reproducible all the time, but I think they have something in the back of their head now that kind of nudges them a little bit, and I hope that this is kind of the seed to keep them going. But I don't know if they really are as meticulous as I'm not, so. But they do take something away from the course, and I should say the course is not mandatory, and they don't get any particular credit other than publishing a paper or something. But it's not a course that students, let's say this way, students do it voluntarily. And so I think I'm getting those students who actually are interested and want to do it later on.
Oh, thank you. I've got questions for two halves, but I'll keep it short. Thank you for a great presentation. I've actually sat in one of your classes, so it wasn't a surprise. But it was interesting. I wondered if you perceived the distinction between replicability and reliability. You didn't mention reliability in your talk, and I wondered if that was on purpose. And leading on from that, I sort of do social science stuff, and it's my perception that in the natural sciences, in the natural sciences, there's a sort of tradition of disproving, providing a counter-argument, providing evidence to the contrary. It seems that there's a climate where that's more welcomed. In social sciences, if you challenge a thesis to which a social science is wedded, you're going to get yourself in hot water. I've done it myself. You celebrate a conference, you say such and such is wrong, and you get this sort of barrage of abuse. So I wonder why the social sciences are so different from the natural sciences in that respect. Is there a sort of philosophical difference or a traditional difference?
Okay. So I'll answer the second question first. So my insight into natural sciences comes from my colleagues, right? So I'm not in that field. I know a lot of people in biomedical sciences and cancer research. And so I feel that these fields are more advanced and it's more accepted to challenge each other. And the trend is much more advanced that you would share your data. So most of the journals in the natural sciences ask authors to provide all their data and their code and be very open. Political science is now getting better and better. Sociology is still in criminology lagging behind a little bit. So I feel that every field or discipline is kind of getting in that direction, but some are just a bit slower. And so that's how the climate is a bit different. I think there's nothing inherently very different in social sciences that makes them inherently non-reproducible. I don't see that, but I think that, especially that since we have a strong qualitative tradition, especially in Europe and the UK, qualitative tradition, so it's difficult to kind of do a lot of the things from the natural sciences. It's difficult to apply them directly to the social sciences, and maybe that's why there's a bit more hesitation. Now, I also have a theory. I think that scandals really help. They don't help the particular researcher, unfortunately. It is painful for them. But I think once you've seen scandals in economics, we had scandals in cancer research, Duke, there was a scandal. And they push the field to kind of go further. And they push the journals, which are really, really important, to ask more of the authors. In political science, we had a scandal at Macron. Anyone heard of this? Yeah. So a student, I forgot the university of California, I think. LA, UCLA, okay. So he had a paper, I think actually published in Science, which is unusual for a political scientist. It was about if you can persuade people to support gay marriage when you go door to door and try to talk to them and persuade them personally. And so his data set apparently was partially made up. And he had said that he cannot share the data due to confidentiality issues. And his supervisor never really fully checked his thesis advisor, and they published that together in this really high journal. And he already had a job offer from Princeton as an assistant professor, and he had a shiny CV, and it was all great. And then it came down because someone tried to replicate it, and it came out that he had made everything up. And so that was fantastic for political science, because suddenly there were a lot of initiatives and a lot of journalists who were previously hesitant, saying if we create a replication policy, maybe authors won't submit to us because they don't want to get into that stuff. And now more and more political science journals are pushing to be more open and transparent. So I think that most fields are going in a similar direction. Whenever you have a scandal, there's a little bump and a little push that we can all use. But yeah, I don't think that social sciences are inherently resistant against this.
What about the concept of reliability?
Yeah. So replicability versus reliability, right? There are so many different terms to talk about replication: reproducibility, reanalysis, conceptual replication, internal replication, and all kinds of other. I think the important distinction is if you just check for errors in someone else's work, reanalyze exactly what they did, versus checking are the results reliable or robust. And so I'm aware that in other fields you would call these things differently. If you write a paper and you justify what you've done and what you want to do, it's good to use the terms in your field and say exactly what you mean by it. That was my way out of when I wrote that paper that I did. But I'm aware that people have different names for it.
Thank you. We've got time for one further question before we move on. So I think it's just from the front. And then there'll be time at lunchtime as well at the end of the day.
Just quite a short comment on the previous thing about scandals promoting the cause. And as I understand it, the Natural Sciences Funding Council in the UK was sort of spurred into action to produce their research data management policy, which went live in May of 2015, directly as a result of the ClimateGate issues at the University of East Anglia. So there's a direct connection between that scandal, if it is a scandal, and the current national policy. So you're quite right, scandals can help.
Are useful, unfortunately, yes.
Yeah.
Yeah.
I think that's, thank you ever so much, Nicole. I think that's really
Thank you very much.